Hello, this is David again at Everything Economics, and today we're going to talk about externalities and economic efficiency. And sometimes we discuss this in when we're talking about environmental economics, because the environment uh, can be a benefit or cost to everybody in some way. And I'll go into more detail in that in the next slide. So, first of all, environmental externalities. An externality is a benefit or a cost that affects someone who is not directly involved in the production or consumption of a good or service. So, one basic example is, for example, if a factory pollutes the environment, that would be considered a uh, negative externality. So let me get my pen out here. So, for example, pollution is a negative externality. And of course, that would be a cost. So the cost would be, of course, fresh air, clean water, and so forth. Um, so even though you yourself are not polluting the environment, if a factory or many factories are polluting the environment, then that's going to direct that's going to affect a lot of people, and that's a negative externality. But externalities can also be positive. So, for example, in the recent pandemic, uh, with the COVID-19 vaccines, that was a positive um, externality. So, the vaccines, which helped us get through the pandemic. So, that would be positive. Let me write this down. Positive externality. Even though you yourself did not pay for the research, or in some cases didn't even pay for the vaccine because they were free for a while, um, we all benefited from the vaccine to help us get rid of the pandemic. So that was a positive externality. So these are costs or benefits that we as individuals do not directly uh, um, cause, but we as individuals may be affected, and it could be a positive effect, it could be a negative effect, and so that's externalities. All right, we're going to go over two questions, and let's go to the next slide. Okay, here we have a graph, and I'm going to go over it. First of all, we have the cost or benefit, and this is dollars per ton. And then on the x-axis, we have the reduction in sulfur dioxide emissions in millions of tons. So this is a reduction. So being a reduction is a positive thing. So we would like more reduction in sulfur dioxide emissions. And we have the marginal cost of reducing pollution. Okay, that's on this line. And then we have the marginal benefit from reducing pollution. So we have the cost and we have the marginal benefit. And here we have dollars per ton. So, for example, we have $300 per ton if you want to really get rid of a lot of pollution. We have the amount in millions of tons, so 7 million tons, 8.5 million tons. And of course, as you can tell, if the more pollution we can get rid of, the better it would ideally be. And then, of course, we have the cost. And question one says, what area represents the total cost of increasing the reduction of sulfur dioxide from 7 million to 8.5 million tons? So keyword is it's looking for total cost. And of course, getting rid of pollution does cost. And think of it as kind of a line where we have uh, absolute pollution. Think of the dirtiest place you can think of. And then we have on the other end of the spectrum, well, let's see, the other end of the spectrum, we have absolutely zero pollution. And zero pollution, to achieve that would be quite expensive. In fact, it would be so expensive that we probably would never even be able to achieve that point. Whereas having complete total pollution, um, it would be great for companies if they could pollute and not have to worry about any regulations, but our environment would fall apart and it would be pretty bad. So we have to think about at some point in the middle, you know, what area are we willing to tolerate? And so the question is asking, what area represents the total cost of increasing the reduction of sulfur dioxide? So we want to reduce sulfur dioxide from 7 million tons to 8.5 million tons. So in this case, the total cost of reducing that pollution is going to be below the marginal cost line. So this line here, I'm just going to kind of dot it with red a little bit. So everything under this line represents the total cost. And so reducing pollution from 7 to 8.5 million tons, the area is going to be B. So area B represents the total cost. Okay. Now we're not going to go into the numbers, but in the next question, we will actually figure out the cost. But just remember that area B represents the total cost from increasing from 7 million tons to 8.5 million tons. All right, if you didn't understand that, don't worry. We'll go to the next example. All right, so here we are with question 2, and the graph is the same exact graph with the same information. However, I just noticed just now that there's a slight error in the graph, and let me just correct that before we even get started. If you go here, this line from 200, this is actually supposed to go straight to the equilibrium point. So basically we have a triangle. I know it's not perfect triangle, but it's supposed to be a triangle there. So I do apologize about that. I just actually noticed it. All right, but here the question is, how much is the net benefit in millions of dollars of increasing the reduction of sulfur dioxide from 7.0 million tons to 8.5 million tons? So if we look at this question, it's asking for the net benefit. So from there, we can deduce that it's going to be benefits minus costs. Okay, so, and then of course it's benefits minus costs of reducing or getting rid of the sulfur dioxide emissions from 7 million tons to 8.5 million tons. So how much is that going to basically, or what is the benefit of that? All right, so now we get into the math part. Now, as I said earlier, this is a marginal cost of reducing pollution, this line here, and this line represents the marginal benefit. So we're going to subtract benefits minus, or take costs and subtract from benefits. All right, so for benefits, it's going to be, well, we know the difference is 7.0 million and 8.5 million. So we're going to just simply subtract those. And I'm just abbreviate M for million. And that's going to leave us with 1.5 million tons. And the amount is at $200. So from this point, and remember it's supposed to be a straight line, so apologize if it looks crooked. From this point to this point is 1.5 million times 200. So we're just going to do that, 1.5 million times 200. And then we've got to add another section, and we have to add 1.5 million tons times 100. So we've got to add this part. So this is going to be 1.5 million tons. It's 1.5 million times $100. And that's, and just in case you're wondering where the 100 came from, that's 300 minus 200 equals 100. So that's going to be 100. And that is going to be times 1/2. And in case you're wondering about the 1/2, that comes from the triangle, because this is basically a square here, and we are cutting that in half, so it's going to be 1/2. And if we put all those numbers into the calculator, we are going to get about $375 million. So let me just write this here, 375 million. And that represents the benefits. So I'm just going to put here B. So that's representing the benefits of reducing the sulfur dioxide emissions. Now we got to get to the cost, and then we'll find out what our net benefits are. So the cost is going to be, let's see, we look at, we have here 1.5 million tons, and it's at the point $140. So we're going to multiply those. So 1.5 million tons times $140. And we're going to add that to 1.5 million times 60. And you're wondering, what is 60? Well, 60 represents the point from 240 to 140, or 200 to 140. So that represents 60. So we're going to multiply that by 60. And again, we're working with another triangle, so we're going to multiply that by 1/2. Okay, so now that once we put those numbers into the calculator, that should give us approximately $255 million. Now we want to find the net benefits. So basically, we're just going to take 375 minus 255, and the net benefits is going to be $120 million. So what does that represent? Well, that means that the cost of reducing sulfur dioxide emissions, the cost of that is $255 million. But our benefits is going to be $375 million. So the net benefit is going to be $120 million. So in this case, you would say, if you were an environmentalist, if you were a lawmaker, or somebody trying to create environmental policy, you would say, okay, this looks like a good idea because we have, our benefits are greater than the cost. And so, yes, we can go ahead and reduce sulfur dioxide emissions from 7 million tons to 8.5 million tons. Okay. All right. If you have any questions, feel free to put them in the comments, and stay tuned for our next videos. Thank you very much for your time.